Hi, my name is Adewale Odayo Grace, a master's student at African Institute for Mathematical Sciences, Kigali, Rwanda. This is a presentation of my statistical machine learning assignment, and this is to understand machine learning better, thanks to my tutor, Professor Ernest Fokwe. In these assignments, we were tasked with regression and classification modeling. Let's dive into it. Regression task. The data used contain 225 rows and two columns. And my two columns are my y and x variable. My y is my dependent and my x is my independent. And the first thing to do is to observe the relationship that exists between my y and my x variable, of which I did using scatter plots, and a form of non-linear relationship was observed, which helps me to choose my function space of a form of polynomial space of degree of atmos p. Now moving on to estimating model performance using cross-validation. My data set was splitted into 10 folds, of which 9 V minus 1 folds will be used to train and the remaining will be used to test. The remaining one will be used to test, and this will be repeated many times until the fifth fold time, until each of the fold is used as a test data set, and this is done in order to be able to generalize my model on unseen data mimicking the population. Having the cross-validation error and the empirical risks as a function of polynomial degree plots, the polynomial degree of order 10 was chosen as my optimal complexity. What do I mean by optimal complexity? Optimal complexity is that polynomial model of order P that minimizes the cross-validation error. That is the polynomial degree of order P where I have my cross-validation error to be minimum. And observing the plots, a polynomial degree of order 10 has the minimum cross-validation error. Model comparison and evaluation. Simple, optimal and complex model was compared to see how well they fit my data. The simple model, that is of order 1, fits a straight line to my data but does not capture the non-linear pattern of my data. The optimal model of order 10 was able to capture the non-linear pattern of my data, avoiding overfitting and underfitting. But the complex model actually fits my data, but there was a deviation from the smooth representation of the true relationship. Now moving on to comparison of the simple, the optimal and the complex model. The simple and the optimal and complex model were compared using the test error, and from the box plots there was no difference between the optimal and the complex model. But to establish that, analysis of variance was carried out with p-value of 0.0241, which is less than my threshold, the 5% significant level, which implies a statistical significant difference in the mean test error. Following this, I move on to a post-hoc test to check the pairwise difference, and I observe that there is statistical significant difference between simple and complex model, but in contrast, there is no statistical significance between the complex and the optimal. Now moving to the second part of the task, which is the classification task. The classification task, I have my data of 4,601 observation with 58 variable of a response variable email type with binary output 0 and 1, that is non-spam and spam. This is the distribution plot of my email type. The proportion of the non-spam is higher than the proportion of the spam. And in this classification task, four learning machine were used: the LDA, the QDA, the FLD, and the naive bias. But in this context, the FLD and LDA, they are doing the same thing in binary classification. Explaining my ROC curve, it reveals the strength and the weakness of each model based on their ability to classify spam and non-spam mail. But observing the ROC curve, the LDA following by the QDA has a greater ability to classify my spam and my non-spam mail. Thank you.